We're back with a Who Wants to Be a Mathematician. I'm your host, Mr. Hill. Last video, I clicked the wrong button, got cut off. Bad news, but that's okay. We're still dealing with parent graphs and describing the transformations, then sketching them. So here we go. Letter E. G of x is equal to the absolute value of x minus 2 squared minus 3. Oh, I have to sneeze. No, we're good. We're good. All right. So now, step 1. Parent graph, parent. This can be a little bit tricky because we have two things going on. We have absolute value and we have an x quantity squared. But if you remember from just the section before, the absolute value of a parent graph, if the absolute value has a whole thing contained in it and there's a parent graph inside, then that's going to be a whole thing on itself. So our parent graph really is going to be our g of x is equal to x squared. So the absolute value in this case is going to be another shift. So speaking of shifts, let's find some. Just kidding. Let's draw our parent graph. So x squared, what does it do? Parabola coming out of the origin. We love it. Let's talk about some shifts. So g of x, start off simple. Let's break it down. X minus 2 quantity squared. We know the 2 is a negative and attached to our x. If it's attached to our x, it's a horizontal shift. So a horizontal shift, we were thinking negative, but it does the opposite. So it really goes right to g of x is equal to the quantity x minus 2 squared. And we're going to subtract 3 off of that. So if we're subtracting off of a quantity, then we're thinking vertical. And we're thinking negative 3, so we're going down 3. So right 2, 1, 2, 3, going down. Now for the kicker. This is where it's really going to get us. Absolute value of the whole thing. What does that mean? If it's absolute value, that means no negative. Oh gosh, negative values. All right. No negative values. We're just going to pretend that says values. So, we've gone right 2. We've gone down 3. So our new origin is going to be here. And normally, we draw something like this. But, what was my last step? No negative values. So my dotted line down here, that's supposed to be a negative, now has to be positive. So, 1, 2, 3. Instead of going down 3, we're going to go up 3. Instead of dotting in a smiley face, we're going to draw a line and a frown. All that happened was that my dotted line got shifted up. So we have another bat boomerang. So our graph, that's not what I wanted. Our graph, g of x, is equal to the absolute value of the quantity x minus 2 squared minus 3 looks like our good old bat boomerang. Perfect. Lovely. Now we're going to move on to g. G of x is equal to the negative square root of x plus 2 minus 3. Step 1 hasn't changed. Find the parent. What's the parent graph? If we take all the numbers away, we're just left with g of x is equal to the square root of x. So we're going to start off by doing what we always do. We're going to draw our little parent graph. So parent graph, there you are. What a proud parent graph that is. Look at him. Step 2, we're going to be looking at some shifts. So, what does g of x do when I add a 2 to my x? If I'm adding it to my x directly, I know it's going to be more horizontal. It does the opposite of what we think. Instead of going positive, we're going to go negative left 2, 1, 2. We've gone left 2. G of x is equal to, ooh, a negative x plus 2. Yikes, we're getting crazy in here. Negative, if we remember, is a reflection. Reflection. And last bit, g of x is equal to x plus 2. And a minus 3. Minus 3 of our whole entire quantity, right? What does that do? It means it's a vertical shift. And the vertical shift is going down 3. 1, 2, 3. So, our new starting point is this dot. I've shifted left 2, down 3. And I'm reflecting of what it looks like. So now, I've reflected. And it looks beautiful. Yes, indeed, our parent graph should be proud because this is what it looks like. All right, so pause the video at this point. Work on B, D, F, H. Go through those on your own. Describe the shifts as I've described them. Horizontal, vertical, reflections, quantity, absolute valued, all those things. And then sketch them. After you've done that, come back to the video. Kind of looks like a Y up there. Bothers me. After you've done that, come back to the video and then click play and we're going to go through them together. So pause, go through them, come back, and we'll go through them together. Alright, and we're back. You should have already done these. So g of x is equal to negative 2 x cubed minus 2. Parent graph. The parent graph. Parent graph is going to be my x cubed. I have a shift of g of x is equal to a negative 2x cubed. It's kind of two things in here. The negative sign reflects. And then the 2 times 2 is going to make it either shallower or wider. Do we remember which one? Do we? I'm sorry, steeper or shallower. It's going to make it steeper. And then the last part, minus 2 is going to be our vertical. We're moving down 2. So down 2. So our new switcheroo points right here. We know it's going to be reflection and it's going to be steeper. If it's reflecting, it's going the opposite way. So my parent graph looks like this. The reflection is going to be looking like this. So I'm coming down. I'm steeper, I'm steeper, I'm steeper. And like this. So remember, it makes it steeper, so you gotta look steeper. So your graph should look something like this. Good. Oh, I scrolled to the wrong. So D, g of x is equal to negative absolute value of x minus 4 minus 2. So 1. What's our parent graph? You guessed it. Absolute value of x. So if we're looking at shifts, g of x is equal to x minus 4. This is going to be the horizontal shift. Negative, so that means we're moving right 4. G of x is equal to negative absolute value of x minus 4. This is going to be a reflection. And then the last part, g of x is equal to negative absolute value of x minus 4 minus 2. If we're subtracting 2 off the end, we're doing a vertical of down 2. So we've gone right 4, 1, 2, 3, 4. We've gone down 2, 1, 2. So our new starting point is going to be there. And we've reflected, so that means we're doing opposite. So if our parent looks like this, we've reflected, makes us look like this. So here we go. That's what you should have done. It looks beautiful. Any parent graph would be proud. Then we got F. F is a great one. Why is it great? Because we're about to do it. That's why it's great. Ooh, getting over a cold, not fun. X minus 1 cubed. Ooh, another cubed graph. Nice. So 1, what's our parent? Parents are proud. It's going to be our g of x is equal to x cubed. Good. So if we do a quick little sketch, x cubed has a little swirly do, 0, 0 is in the middle. So 2, we're going to do our shifts. So g of x is equal to, start off small, x minus 1 cubed. It's supposed to be cubed. Alright, come on. Cubed. What does this do? 1 is detached, so we have a horizontal shift. It's going to go right 1. Oh my gosh, we don't even have our coordinates. Come on, Mr. Hill, get it together. We're going to go right 1. G of x is equal to negative. Ooh, here we go with a negative again. What's the negative do? It's a reflection. So if it did look like our blue, we reflected. It looks like this. And then the last part, g of x is equal to negative quantity x minus 1 cubed plus 4. Nice. What is our plus 4? It's a vertical, and we're going up 4. So 1, 2, 3, 4. So our new middle point's right there. And we have a reflection, so we're coming down from the top. So coming down from the top, and we're doing something like that. That's a beautiful graph. Any parent graph should be proud of that as well. Follow up. Last one. Coming up at you hot. H. G of x is equal to 3 plus 1 over x plus 1. Nice. Step 1. Parent. What does our parent look like? Well, if we take away all our numbers, it's going to be g of x is equal to 1 over x. Nice parent. 2, we're going to talk about shifts. So g of x is equal to, start off small, 1, x plus 1. Now here's the crazy part. The 1 is attached to the x. That means it's going to be a horizontal. Horizontal what? Positive 1. We're going left 1. So g of x is equal to 3 plus our whole quantity. And what happens if we add a quantity? We have a vertical. A positive 3, we're going up 3. Oh my gosh, we forgot our coordinates again. Bring them back. Here we go. Left 1. Up 3. 1, 2, 3. So here's our new ghost center point. So if we quickly draw our... Ooh, I'm actually really bad at putting that over the 1 part. There we go. So if we draw our dots, because we know it can't equal 0, we're coming down from the top. We're turning. We're making nice little ramps. Here we go. Perfect. That's our parent graph. Nice job, everybody. Alright. So, one more video to go. We're going to go reverse process. We're going to give you the graphs, and then we got to find the function from it, the equation. So, see you next time on Who Wants to Be a Mathematician?